Interval. All the numbers between two given numbers. Example. All the numbers between 1 and 6 is an interval. All the numbers? Yes, all the real numbers that lie between those two values. Example. The interval 2 to 4 includes numbers such as 2.1, 2.1111, 2.5, 2.75, 2.80001, pi, and lots more. Including the numbers at each end? Maybe yes, maybe no. We need to say. Example. Boxes up to 20 kilogram in mass are allowed. If your box is exactly 20 kilogram, will that be allowed or not? It isn't really clear. Let's see how to be precise about this in each of three popular methods. Inequalities, the number line, and interval notation. With inequalities we use greater than or equal to, less than or equal to. Example, x less than or equal to 20 means up to and including 20. In interval notation, we just write the beginning and ending numbers of the interval and use a square bracket when we want to include the end value, or a round bracket when we don't, like this. This shows the choices we have to include or not include the ending values of 0 and 20. Example. Here we are showing the interval from 5 to 12. Do not include 5, but do include 12. With the number line, we draw a thick line to show the values we are including and a filled-in circle when we want to include the end value, or an open circle when we don't, like this. Example, this means all the numbers between 0 and 20 do not include 0, but do include 20. Here's a handy table showing all three methods. The interval is 1 to 2. Pause the video and have a good look. Example, to include 1 and not include 2. Another example, the nothing over $10 sale. That means up to and including $10. And it is fair to say all prices are more than $0. As an inequality, we show this as price less than or equal to 10 and price greater than 0. In fact, we could combine that into 0 less than price less than or equal to 10. On the number line, it looks like this. And using interval notation, it looks like this. Example, competitors must be between 14 and 18. So 14 is included, and being 18 goes all the way up to, but not including, 19. As an inequality, it looks like this. 14 less than or equal to age, less than 19. On the number line, it looks like this. And using interval notation, it is. The terms open and closed are sometimes used when the end value is included or not. These are intervals of finite length. We also have intervals of infinite length. We often use infinity in interval notation. Infinity is not a real number. In this case, it just means continuing on. Example, x greater than or equal to 3. Note that we use the round bracket with infinity because we don't reach it. There are 4 possible infinite ends, and we can show no limits by using this notation. We can have 2 or more intervals. Example, x less than or equal to 2, or x greater than 3. On the number line, it looks like this. And interval notation looks like this. We used a U to mean union, the joining together of 2 sets. Note, be careful with inequalities like that one. Don't try to join it into one inequality. This is wrong. It doesn't make sense. You can't be less than 2 and greater than 3 at the same time. We just saw how to join two sets using union. There is also intersection, which means has to be in both. Think, where do they overlap? The intersection symbol is an upside-down U. Example: the intersection of these two intervals. The first interval goes up to and including 6. The second interval goes from, but not including, 1 onwards. The intersection, or overlap, of those two sets goes from 1 to 6, not including 1, including 6. An interval is all the numbers between two given numbers. It is important to show if the beginning and end number are included. There are 3 main ways to show intervals: inequalities, the number line, and interval notation. You may not have noticed this, but we have actually been using algebra, geometry, the number line is a line, and sets, an interval is a set of numbers, all in one subject. Isn't mathematics amazing? You can visit us at mathisfun.com.